So, I fixed something, perhaps. So, there's a new type of presentation format. I'm not sure if I like it and whether it works, but some of the things we had before with like overflowing brackets, so that might have been fixed. So, I might have actually solved something. So for today, it's the last lecture. Last week we covered multi-level models, and today, actually last week you'll be able to do most of the multi-level things already in your assignment, and today it's the final thing, and mostly it's about making some pretty graphs, and I give you some examples, and that's the type of thing you'll also have to do for your assignment. And I think I might solve something. Remember those overflowing code bits in between, and this is done via the Saringen package, which makes really nice layouts. We'll see how it looks and how it plays. The only downside might be that when it prints a PDF, it will print all the intermediate steps as output as well. But so far, it's looking quite nice now. Look at the pink and like the black and the white. It's quite nice. So I'll just run you through making some graphs, and what we now have here is a bar. So that doesn't allow me to. It allows me to move the cursor, not drag. So I'll just do it like this. But now we have the code like we can see the entire thing where it wouldn't overflow. So this is just reloading the exam data which we saw from last week, and then we're building a fixed predictor model, which a random intercept. So that's the random intercept, yeah. And then we put RML as false, just for this model. We're going to try and make a plot, and because there's 65 schools in the data, we're not going to show. Is there a problem? Is it?
No.
So I just randomly, I just sort of picked 3 schools to illustrate what's going on. So if you do normally with facet wrap, you would get all 65, and that might be a very busy panel. And also for your assignment, you're asked to make just a couple of schools rather than the entire school to illustrate the pattern. You could put all the schools on it, but it's just going to be an extremely busy graph because you're going to have 65 different small panels to look at. But usually it's quite useful to take a subset, see what's going on, and see what's happening here. So here, the first step is with dplyr, I make a subset. I pick school 1, school 17, and school 18. And then we make a multi-level plot, and we use ggplot, which you should know by now. Those are the aesthetics, so the x and the y type of dynamics. You should have remembered also from the first assignment geom jitter to avoid overlap in points. Yeah, and we can also change the transparency of it by the alpha. And what we also do now is we have a facet wrap, so we wrap it by school, so we can see all the schools differently. And then we have some labels. So as you might remember, it was the London Reading Test, and they have some type of normed exam score at the end. So the goal here is to basically see what's happening within certain schools and seeing if those patterns differ. And then we have a linear model, so we just have a smoothing function to sort of show us what's going on. So just a line through all those points, which will show us what's going on. And then we also want to have some type of intercept line, perhaps. And so via H line and V line, we can put arbitrary lines one way or the other. And I just tell it that it has to. I just tell it it has to be at 0. And I also tell it I want a dashed line. And you can pick different lines. You can have full lines. You can have point dashes. You just all look at the commands. And then I pick a team, and you also, by now, you should know that you can pick different teams. So for your assignment, you have Team Tufte, and so there's all sorts of teams already present, and it will make it look slightly nicer. So look at the pretty. So this is what we have here for 3 schools. So it's done the labels. So it's done the London Reading Test. It's done the normed exam score on the y-axis, and it's put a regression line with some smoothing and so those bands are the 95% confidence intervals for those things. So you can see that the pattern sort of differs between the schools quite clearly, in the sense that you can see that the angle differs. So the reason we want to have multi-level models is we want to account for the fact that within each school the pattern might be very different. So that's what that's why we set it up to do. So the range, so you could think of these as z-scores, most likely, because they're all normed, so they go from -2 to 0 to, and here they also go from that type of range. So you can see, depending on which school you're in, the London Reading Test is more or less predictive of what you actually do in terms of outcome, and you can see also like how strong the slope is. That also tells you sort of what a school does, in the sense that in some things it accelerates, and some things it decelerates the initial gains of how well the children are reading. Yeah, so that's quite useful, and you'll be. So the positive thing is that it shows the actual data, but it doesn't really show what happens in multi-level design. So I'll have some plots for you now, really to show what's happening in multi-level designs. And so you'll be making a similar type of plot for your assignments. The only difference would be that you're using fitted data rather than the actual, just for every single school, the predictions you make at the moment. So you would first do a multi-level model, you would save the predictions, and then you would use those predictions to plot those. But all those things you have in the description. Oh, just trying to load my software updates. So can we have a graph which demonstrates everything? Yes, we can. So the illustration is based on so most of the times when you do coding things, it's just also looking at other people's code and trying to copy what they've done and trying to adapt it to your project. So I didn't develop this, and I just took this from somebody else to make a nice illustration. So we first generate a pooled model, and so this is just not taking into account any of the score things. So you should see this as a linear model and just has normal. So this is not taking into account any of the class things. So we can save the predictions for that pooled model, and in a similar way, you would do that for your multi-level model. You can just add predicted or fitted, and it will save the predictions from your model to that, and then you can use them for plotting. So basically, you're asking the model to make a guess, and you can use those scores to then do further plotting. So what we then do is we make a variant intercept model. So again, I'll have to do some scrolling here. So. And we do that by just doing a linear model at that level. So it's just that type of command will give you a varying intercept, just as a linear model, without building a multi-level model, but just to illustrate what's going on. And we can again get the fitted variables, the fitted predictions from that. We do the same thing for random slope, and so this is stand LRT nested in school, yeah. And again, we use fitted to get the predictions, and then we can also get what's called an interaction model, or a model with both a random intercept and a random slope, and it's just those two. So standard LRT plus school. So those two. So that line of syntax and that line of syntax combined into a single model. Yeah. So it's nothing you've not seen before. It's all linear models, and we can again save the predictions. And now we can make some pretty graphs. So again, I make a subset. So I make a new subset, and again, I pick school 1, school 18, school 21, school 40, school 55, school 59. So now I'm going to show you six panels. Yeah, 6 panels, and then we're going to see what's going on in those groups. Again, you could pick different numbers. To be honest, I toyed around a little bit to show you some type of things where you could more clearly see that there are differences between the groups. Now, again, it's ggplot. The subset is the data set. These are the aesthetics. Before I didn't say x and y, but you can also explicitly label and say x is this, y is this, in case you forget. But normally, the first thing in order is the x. The other one is the y-axis. We want it to be grouped by school. Yeah. In this case, and then we add a line for the pool predictions. So those predictions don't take into account all the school things. So that's basically, if you were to just collapse everything and not build a multi-level model, that's just your ordinary regression line. And then we can have varying intercept predictions, and we're going to plot those in blue. And then later on, you can see we're going to add red and black, and then that sort of will illustrate what's going on in the multi-level model. And again, we add some points. We change the size and we change the transparency. Here I didn't add any jitter, but you could add jitter as well to make sure that the points don't overlay. And then we do a facet wrap by school. And then we just have the labels again which we wanted to have on the bottom, and again we have a team. So those are just X and Y labels which we had before, and we can see what this looks like. So the black line is what you would do if you just pull all the data and have a regression, and the other one sort of accounts that it can be different for schools, but only the shift can only be upwards or downwards. It's not changing the angle, so that's a random intercept type of model. So for some things, so for group 18, the blue line is very close to the gray line. And for other ones, we might be over or underestimating in this vertical dimension. So that's what happened. That's what's happening in an random intercept model. So just we're getting a better estimate, sort of to speak, because now we're using the blue line, so to speak, to make predictions rather than the gray line. And so it's taking into account that the data is coming from these different small groups. Yeah. So that's just, but it's just a shift in this type of vertical dimension. It's not doing anything with the angle. You might think it's doing something with the angle, but that might just be a visual illusion because of how the points are plotted. But the angles are nearly always the same or parallel to the line. It's just some type of things, but it's just doing this dimension. Yeah. Any questions? So now we do the same thing, and I already put in this thing. So with the hashtags, I can actually mask the things which we don't want to plot, and so it's exactly the same code as you saw before. But now we're going to put a red line, and the red line will just do the angle. So it's will just allow the by school the slope to vary as a function of the London reading test. Yeah. So what you see here is that this slopes are shifting. Yeah. For some things, again, so for group 21, it is close to the angle is nearly the same for the pooled line as for the regression line within that group. But for other things, we're making better predictions based on the angle. Yeah. So this is taking into account that the effect of the London reading test might vary between within those schools, and also between them in the sense that you can see that the angle is sort of shifting. Any questions? So that's just doing this. It's not shifting the line up or down, because that's the next thing, which is where we're going to do both. Yeah. And that's known as the interaction model, or a model where we have both a random intercept and a random slope. And the goal here is to try and see if we can optimize the prediction of that cloud. And so with the gray line, we might be making lots of errors, so to speak, and not taking into account that patterns might vary between the schools. And if we do a combination of the red line and the blue line, we might be getting better estimates as to what's happening with the London reading test and the normed exam school in every single school. Okay, so the same type of thing, but now we have a black line rather than a dark gray line. And again, all the other code is just the same from before. And now we can see that we're doing both dimensions, so we're both doing angle as well as the shift. Yeah, and you can see for some things, well, nearly in all cases, we might be making a better prediction in the case that if you see how the black line fits through the clouds, it's doing it more accurately, trying to capture more of the points. I didn't put the confidence intervals, but we'll be capturing more points if we put smoothers around it than with the gray point. So any questions on that? So this is just, so we're trying, so that's basically what's happening in the multi-level model, and that's perhaps what might not have been clear last time as to why what is happening with the shift upwards or downwards, but hopefully now you get it. And what we're doing here, I've just illustrated for those 6 schools, but you're doing for all 65 schools, or however many are in your data set. Okay, now you get to try it yourself. So we'll get to wash up the stink of failure. And so you take the data from last time from the Scottish schools, and you just try to make the type of graph, those 3 types of graphs which I made, and you can just copy and paste the code I have, but you'll have to change some of the commands because the variables are different. And if you're unable to download the data, I've now posted them also on Blackboard, and you should be able to get them from Google Sheets.